Good morning, all. We welcome you all for the next lecture series. In this series, we are going to discuss about the architecture of 8086. So, I think for the last class, we have discussed about the introduction of microprocessor and what are the what are the parts it consists. That is ALU register, register array, control unit. So, what is mean by arithmetic logic unit and register array and control unit? We are discussed in the last class, and this is the block diagram of your microprocessor, which consists of input device, output device, memory area, and also the processor. The processor consists of ALU control unit and then register array. We are discussed in the last class, and the working of microprocessor, we know that first it fetch the instruction and decode the instruction and then execute. I think for the last class I'll discuss with you with an example. So today's class we are going to see the architecture of 8086. So the functional units as two units are there. One is execution unit and then BIU unit. BIU means bus interface unit and EU means execution unit. So normally the microprocessor is consists of 20-bit address lines and the 16-bit data, and it is work in the mode of two modes. One is maximum mode and then minimum mode. So maximum mode means number of processor is handled, then maximum mode is chosen, and for the minimum mode it consists of only a single processor, and it is having three type of futures, that is based on the frequency. One is 8086 consists of 5 megahertz, and 8086 version 2 is 8 megahertz, and version 1 is 10 megahertz. So and then it has two, already I mentioned, it has two functional units. One is BI units and then execution unit. So BA units consist of stack segments and then a queue and then control unit, right? So what is meant by segmentation, segment register? There are four type of segment registers are available in this microprocessor 8086. It is especially available in 8086 only, and based on the segment register address, the 20-bit address will be made, right? So that is for based on the instruction, the get the data from the segments, the extra segment, the code segment, stack segment and data segments. Then the last one is IP, it is the instruction pointer. I'll tell you after the segmentation. So instruction segmentation data are based on the instruction we are making, right? So here the another block is there. One is instruction system queue. It is in the byte. It consists of 6 queues. So normally compared to 8085, 8086 speed then 8085, because of the queue is available. That is 6 instructions are on the pipeline and stored into the queue. First instruction is executed by the execution unit, and after complete the execution of first instruction, they get the second instruction from the queue itself. No need to get the instruction, and no need to wait for the instructions after execution. So based on that, the speed will be increased. So next is I told you IP is instruction pointer. So instruction pointer point out the next instruction is going to be executed. So that is the address will be in the IP. Next instructions address is available in the IP, right? And the next functional block is execution unit. So execution unit consists of general purpose registers and arithmetic logic unit and operators and flags. So arithmetic logic unit already I mentioned in the last class itself. It performs the arithmetic operations and logical operations. So operands means the mnemonics and operand, and then flag also. So 16 in 8086, 16-bit flags are available. So flag is consist of the performance of the accumulator or the instructions. So for example, if you are having a or executed the instruction by the execution unit, and the result will be stored into the flag. It shows the condition of the instructions, right? So, and next one is general purpose registers. Why it is called general purpose registers? It is used by the users, then it is called as the general purpose registers. Normally there are A register, B register, C register, and D register, and SP stack pointer, base pointer, and DI is data instructor. So all the devices are in the general purpose registers, right? For example, if you are taking add A B, that is add A comma B means there are two data are available. One is in the B register, another one is in the A register. So B register data is added with an accumulated data, and the result will be stored into the accumulator, and the condition of the result will be shown in the flags. So, for example, it consists of a carry. If it is carry created or not created, the carry, and auxiliary carry, and 0 if it is available in the 0, then 0 flag will be initiated, and the data will be in the that is it consists of minus 2, then the it shows in the flag, right? So I think I explained all the blocks. Then all the blocks are connected with the bus. So what is meant by bus? I think for the last class I mentioned in the introduction class, that is bus is the group of wires which is carry the data from one blocks to the another block. I think you all having a knowledge about the architecture. See you in the next class. Thank you all.